Hello, Physics 207 virtual lab students. I know it is a little bit struggle working on the tracker, and this being the first lab that you're working on. It might it takes a little bit time to get practice and get into the system and learn about it. So we will be using the tracker for next couple of labs. So it's good to get used to it and understand like what is the process here. So I'm creating this video to walk you through the tracker and show you like how it's work and how to create the graphs and how can we analyze those graphs. So let me share my screen with the tracker. Before that, first thing you should do is you need to go to the Canvas page, and here's the assignment. So you can download the tracker app, or if it is not working, use the website. So it can work on the browser, but it might take a little time because it's running slow on the browsers depending on your computer and also the internet speed. However, the recommended way is to use the app, which is easy. Well, after that, of course you need the motion graph manual. Then after that, if you scroll down, you see this couple of videos. So if you didn't have the time to create a video, or your video is not that good enough to do the analysis with all these requirements, you may use these videos. That's perfectly fine. So what you have, it doesn't need to play on here. Just right click and save the video to your computer, create a folder, Physics 207 lab, and label this as video 1.1. So you have a record of video on your computer. Once it's ready, go to the tracker. So here I open the tracker, and then you go to file. Then there are many ways to do it. Either you can import the video or just drag and drop the video over here. I like to import, so I will import it from my folder. So it's my 1.1 MP4. I select that and then I open it. So it will get into the tracker and it's easy for me to analyze. Then you see these numbers on the screen. If it is readable, you're perfectly fine. If it is hard to see, you can change the size of the video, like zoom in a little bit more so you can see the numbers clearly, because calibration is a really important part in using the tracker. So here you see the calibration stick, and you click on it and go new and pick calibration stick. So you see like here it's 40 to 50, that is in centimeters. So I'm going to calibrate this, saying, oh, length from here to here is 10 centimeters. So when I'm taking the data, it really reads the correct value with the correct unit. So to select that, after you select the calibration stick, what you have to do is you come to the 40. If it is still not clear, you can change the size and make it visible more. All right, so here is 40 and here it is 50. So I'm going to go click the shift button. So it will appear an icon like that, and then I'll mark it as here. I just click on it with the shift button pressed. And then I move my cursor to 50, and then again, I click on the shift button. So it's appeared here. It need to be in a straight line. So make sure you have it like horizontally straight over here. So it's not diagonal. I am moving my cursor like straight here to 50. Right, so that is the stick. And this is not 154.8 meters. It should be 10 centimeters. It's better to have meters as our unit because meters is our SI unit to measure the length. So what I do is I will mark this as it is 10 centimeters. So it's going to be 0.1 meter. Right, so that is it. So that's calibrate the length. It is 10 centimeters here. Yeah, 0.1 is 10 centimeters. All right, now then the next step is to define our origin. So what I do is I will zoom it out. Okay, so it's 100. Actually, before this, you should have done like selecting the frame. It's perfectly fine. You can do it at any time. So let's select the frame that I'm interested. So if I move this cursor, I see that the card is coming and running all the way across the screen. I like to analyze it from, let's say, 30 centimeters to 60 centimeters. It really doesn't matter. You can pick 10 centimeters. That's okay. but it's better you pick a longer distance so you get more data, so your data can be analyzed a little better than having only a couple of data points. So I would like to start from somewhere here. So what I do is I will select that frame by dragging this little arrow icon, and I keep it somewhere there. And the end point, I like to keep it before it passes 60 centimeters. So I will keep it like somewhere there. So just past 60. All right, so this is the frame that I'm going to analyze. Now I can go back to the beginning by click on here. All right, so we did the calibration and we pick the frame. Now what I'm going to do is I'm going to select my origin. So here you see this axis diagram or a symbol. So you click on it and it will appear a line like this. So what I'm going to do is I'm going to align it somewhere here. I like to call 30 centimeters as my origin. It really doesn't matter. You can keep it here. That will change the start position, nothing else. So I'll keep it here. It doesn't matter. So I'll keep it there. To be safe, I'll keep it as 30 because that is my frame start. So I will keep it somewhere here, just past 30, because it is my frame starting point. If you keep somewhere here, it will read some extra numbers. So I'll keep it a little past my frame starting point. All right, so we're good to go. Now we have to do, what we have to do is collecting data. So here, one thing you need to do is you need to select a position on the card that can be visible easily. So you see, like you can pick the in front of the wheel, or maybe this white icon over there, or this edge of one of these corners. So I would pick this white corner here. You can pick any point. It really doesn't matter as long as you consist with the same point. So here I'm going to create my points. Before that, I let this card like come closer somewhere here so I can read it properly. See, I'm going to keep my white color point up here somewhere by the origin. And then I create a point mass somewhere there. So I'm going to actually, if I keep somewhere here, I can easily go horizontally very nicely rather than like moving across. However, just to be clear, I think I will pick the point over there so I can easily visualize it. So I click on the shift button and I click over here. Now, once you click on that, it will start moving by frames. Now see that point has moved. Now I click on the shift button and I'll keep clicking on the same point of the card. So I click here. So likewise, I'll keep click on that same point. So it will create data points. So I have a little bit practice on doing this, so I can keep it like in a straight line. If you are doing it for the first time, you might make a little here and there dots. It's okay because you are doing it for the first time. Keep trying. Also try it like at least 3 times doing this whole procedure. So you will get used to it and you will get a little bit clean data. If you click like here and there in a point, then the data will be really messy. Like it's going to be a little bit like rough data, lot of trash data. So it's better to keep like this. Keep collecting data points until it's come into the frame. So I keep going. Now how I'm doing this, I click the shift button and then I click enter. Go. Here it is. I think I made a mistake there. It's okay. So couple of data points might be misplaced from that one, from the graph, but it's okay. We are going to do best fit lines or curves, so it will minimize the error there. All right, so keep doing. All right, so that's the end of the frame. So I'm done. So this is kind of a motion diagram. So I catch the motion of one of the parts in the cart. So you can pick any point. You can pick here or the front of the wheel or back wheel. It really doesn't matter. As long as you collect a bunch of data like in this graph, you're perfectly fine. That's it. So that is part 1, collecting data. Now let's talk about the data analysis. So to analyze, you're not going to use Excel or anything. You're just going to use the tracker and use its graphs unless you really want to do it on Excel. So easiest way to do is you go to the graph and double click on the graph, maybe shift and double click. Or double click here, it didn't work. So I'll click shift and then click on the graph. Maybe I had another one open, so maybe that's why. However, oh, actually it's open, you can see it. So let me open the graph for you and then we go from there. Oh, so it should be a new share. Stop sharing. I'm going to share the graph with you guys. All right, so here's the graph. I believe you can see the graph here. So this is our graph for the position versus time graph. Now, these are the data points. It's not a best fit line, but you will see analysis button here. If you go click on curve fits, it will give you more options to do that. So you can fit it either linear fit or a exponential fit. So in the first graph with the position and time, what we're going to do is we're going to fit it as a parabola, right? So click on a parabola and you see the equation x equal a t to the power 2 plus vt plus c. Isn't it sounds familiar? It's kind of a kinematic equation, right? So think about a kinematic equation that has the same format as this one. So vertical axis is our position, horizontal axis is time. So this t is really the time, x means the position. So position equation, right? So think about that equation of the displacement. So x final or the final position equal half a t squared plus vt plus the x initial. So that type of kinematic equation is familiar with this equation format, right? So this is what you're going to do. So basically a means half of the, a is half the acceleration and b is the velocity and c is the initial position. So here let's read these numbers and record it in the given space. All right, so that is one graph. And then you need to draw the velocity. So what you have to do is you click on this x value here. Actually, you cannot do it on this graph. You have to go back to the tracker. You go to the tracker, and here if you click on the axis here, you can change what you want. So let's say you want the velocity x, horizontal velocity. See, these data points are jumbled here and there. This cut is moving with a constant velocity, but these are my errors of clicking on this data point. So it's okay. This is a real experiment that you're doing using a real video. So errors can be made, right? It's perfectly fine. You go do a best fit line. So it will average the error and give you a proper data. So yeah, I think you can see the graph from your screen. So let me share it properly. This is what it is. You see on my graph, I have both a position and the velocity. I don't like to have that happen. So what I do is I go here and then I unclick the x values, so I can filter only the velocity in x-axis. Then I don't like the parabola. I like to get the linear fit. So you click on linear. It will do a linear fit to you. Now look at this equation. It's velocity equal at plus b, right? Isn't it looks familiar? It's velocity function equal at plus b. I will leave it for you to think. And anyway, so think about it. It's a velocity on the y-axis and time on the x-axis, and look at this equation and make a match with the kinematic equation. So you will see like what is a and what is b. So here, here you can read the numbers a and b values. So that will be easy. Now, when you're reporting this data onto your lab report, make sure you either screen clip this or make a copy of these graphs, and you can insert onto the lab report before you submit the lab report. All right, so I think I had a video about like how to do screen clipping. Anyway, I know you guys are familiar with all of these edits, so I'll leave that to you. I hope this video will be helpful. So please work on the lab report, and I hope you will submit a good lab report to me.